Just a short bit of theory to finish off the lesson in the last few minutes. If you haven't finished to the end of question 5, please complete that for homework. I find myself in the happy situation of being able to give you just a little bit more theory that I wasn't going to. So that's really good. And I just want to produce the formula, which is on your theory book, on your information sheet. But again, understanding the whys and wherefores is key to being able to understand where to go with this kind of stuff. So we've got the formula is sine squared x plus cos squared x equals 1. And for those who haven't done it before, when you put a square between the sine and the x, it's just a notation. And what it really means is take the value of sine x and square it. If you add the square of the value of cos x, then you'll get 1. Okay, so sine squared x plus cos squared x equals 1. Sine of x all squared plus cos of x all squared is equal to 1. Same deal. Now, the reason why the formula works is really simple. We know from our coordinates that if I've got a hypotenuse of length 1, then the opposite side, whoops, stuff that up. Try that again. The opposite side is sine x, and the adjacent side is cos x. Yeah? That's just basically how we defined it, right? The horizontal distance is cos x, and the vertical distance is sine x. So if I use Pythagoras' theorem, which we're going to use a lot over the next couple of lessons, Pythagoras' theorem, then sine squared x plus cos squared x is equal to the hypotenuse squared, which is 1 squared, which is just 1. How good is that? Nice and easy. That's where it comes from. Of course, it makes no sense at all unless you buy into the fact that with a hypotenuse of 1 on the unit circle, we have cos x and sine x as the sides of our triangle. If you're not there yet with understanding that, just let me know and I will, again, diagram that out a bit more for you. The reason why we do it, why we have that Pythagorean identity, is because it allows us to solve these kinds of problems here. So what I can do is I can say that sine squared x plus cos squared x equals 1. Sometimes I put brackets in, sometimes I don't. It's just a notation thing. That means I've got 0.6 squared plus cos squared x is equal to 1. 0.6 squared, 6 squared is 36, so 0.6 squared is 0.36 plus cos squared x is equal to 1, which means that cos squared x is equal to 0.64. Okay, 1 minus 0.36, and cos x is equal to 0.8. 0.8 times 0.8 is 0.64. Okay, so now we've got a value for, sorry, I don't know why I changed that to sine. I didn't mean to. Cos x is equal to 0.8. I don't have a lot of room here, so I'm just going to tuck it into the corner here. Tan x is equal to sine x on cos x. So that's going to be equal to 0.6 on 0.8, which is equal to 6/8 or 3/4. Sorry for being a bit squishy there on the end. Okay, and again, if you're wondering where that identity comes from, tan x equals sine x on cos x, it's in this in this triangle as well. Tan is opposite over adjacent, so it's sine x over cos x straight up. So there you go. So what it allows us to solve problems like sine of x is equal to 0.6. What is the value of cosine of pi minus x? Well, then you can do that, right? You can say cosine of pi minus x is going to be negative 0.8. So again, if you're given the sign of a value, you can use the Pythagorean identity is what it's called in order to work out cosine and tan. Once you've got cosine and tan, you can then solve problems like this. That will do us for today.